Alright, so in this video I'm going to be talking about biomolecular event extraction, and we use maximum entropy. So this model considers event generation. I'm going to be explaining this paper in 2015 from Journal of Information Processing Systems. For bioevent extraction, most approaches first detect the triggers in a sentence, and then they obtain the edges that represent the relationship between a trigger and its arguments. Also, they actively utilize dependency parsing information to detect the edges. This is because several approaches have already improved their performance by using features extracted from dependency parsing information. In this paper, we propose a maximum entropy-based model which can mathematically explain the biomolecular event extraction problem. The proposed model generates an event table which can represent the relationship between an event trigger and its arguments. The complex sentences with distinctive event structures can be also represented by the event table. Previous approaches intuitively design a pipeline system which sequentially performs trigger detection and arguments recognition, and thus did not clearly explain the relationship between identified triggers and arguments. On the other hand, the proposed model generates an event table that can represent triggers, their arguments, and their relationships. The desired events can be easily extracted from event table. So in this paper, we propose a model for biomolecular event extraction that estimates the probabilities for generating all possible sets of biomolecular events from a sentence, and that selects the best event set with the highest probability value. So this is an event example which is extracted from an analyzed sentence. You see the name entities, you see the parse tree that we are leveraging this syntactic information for better event extraction. So figure A is correct, but figure B is missing correct trigger. So this one is incorrect because it's missing the correct trigger. For example, figure D is incorrect trigger again. And figure F is missing the correct trigger. So our proposed model changes the event extraction problem into a problem of generating an event table, which includes both unary entries for triggers and binary entries for arguments, for a purpose of significantly simplifying the process of solving an event extraction problem by focusing only on the binary relationship between an event trigger and each of its arguments. The proposed model converts the event table generation problem into the problem of generating each entry in the event table. In this chapter, we propose a maximum entropy-based model for biomolecular event extraction. As shown in this figure, the proposed model consists of a pre-processing step while analyzing the given document by using natural language processing tools. So by generation of event, we create our event table, and from that, then event extraction is easy. So we have event table corresponding to event set. Of course, this style, in recent years, there is nothing or very, very few papers working on this paradigm for some reasons. So as you see in this figure, the event table consists of entries containing the trigger or argument type. For example, entry X and Y represent trigger argument relationship between X word and Y word. For example, X word is this, Y word is this, EXY. For example, entry E44 includes the argument type theme, which describes the fourth word. So the proposed model estimates the probabilities of generating the sets of bimolecular events from the document and selects the best event set with the highest probability. So when we say S sub I and E, it means that the I sentence in the sequence. So we want to maximize the probability of event given your document. So what can we do? We say what is the probability event 1, condition on S1, probability of event 2. But we can simplify this by saying that because this one is complex, this one is very complex, we just say condition on the first one, because this is just an approximation. We don't need to be exact, we approximate the problem. And because an unnamed entity indicates that there is no event, the sentence set is removed. So the sentence set and the event set are replaced with the sentence sequence and the event set sequence. So you see that it is simplified like this. But in order to extract events from an arbitrary sentence by freeing oneself from the position of sequence, we assume that the event set can be represented as the proposed event table. So beginning with entries that represent trigger argument relationship between two near words, it also generalizes multiple events by use of the chain rule. And so this means that the X minus ith word on the left context of the word. This is, of course, is very old-fashioned. We are just trying to create some features. You know, the feature and the description of that is here. But the interesting thing in this paper is using maximum entropy. You want to solve the problem of event extraction by effectively estimating each probabilistic term. So what is the probability of cause and protein given that something? Then we say we have K features. So this is again an old-fashioned way. We are manually creating these features and then learning the parameters, and then this is what may appear.